Welcome to the DIY Honda Garage channel. The DTC P050B relates to a malfunction in the cold start ignition timing control system for the 2011 to 2017 Honda Odyssey. This system is essential for ensuring correct ignition timing during cold starting conditions. Ignition timing is critical as it influences engine performance, emissions, and fuel consumption. When the engine is cold, the control system adjusts timing to optimize combustion and minimize emissions. This code indicates that there may be insufficient performance in this adjustment process, potentially affecting engine starting and operation. When diagnosing this issue, it is crucial to understand the components involved, including the crankshaft position, CKP sensor, the coolant temperature sensor, ECT, and various air intake systems. The malfunction indicated by DTC P050B relates to several key components within the vehicle's ignition timing control system. Primarily, the crankshaft position CKP sensor plays a crucial role in monitoring the engine's position and calculating the timing of ignition events. This sensor provides data to the engine control unit, ECU, which is necessary for the proper timing of fuel injection and ignition. Additionally, the engine coolant temperature, ECT, sensor measures the temperature of the engine coolant, allowing the ECU to adjust timing based on the engine's thermal state. The air cleaner housing is another important component that prevents contaminants from entering the air intake system, ensuring a clean air supply for optimal engine performance. If these components malfunction or provide inaccurate readings, it can lead to severe engine performance issues. Several potential causes could lead to the P050B DTC being triggered, affecting the cold start ignition timing control system. One possible issue is a blocked or incorrectly installed intake air duct, which can restrict airflow to the engine and impact the air-fuel mixture needed for efficient combustion. Additionally, if the air cleaner housing is damaged, it could allow dirt and debris to enter the intake system, further exacerbating the issue. A dirty air cleaner element can also obstruct airflow, resulting in inadequate engine performance, especially during cold starts. Each of these factors can disrupt the intricate balance needed for optimal ignition timing and overall engine function. The symptoms associated with DTC P050B can significantly impact vehicle performance and drivability. A common symptom is engine misfires during cold starts, which may manifest as harsh vibrations or failing to start properly. A rough idle when the engine is cold often indicates that the ignition timing is not set correctly, causing uneven engine operation. Additionally, drivers may notice a reduced fuel efficiency due to improper combustion resulting from the control system's failure to adjust timing correctly. Being aware of these symptoms can help in diagnosing the underlying issues related to DTC P050B, prompting timely repairs and maintenance. The first troubleshooting step in addressing DTC P050B involves turning the ignition switch to the on-to position. This action powers the necessary systems to perform the diagnostic check. Next, it is critical to utilize the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs. Identifying other codes can provide additional context and narrow down potential causes for the ignition timing problem. If additional codes are present, they may indicate compounding issues that could affect the ignition timing control system's performance. Understanding each code will guide you to the correct troubleshooting path. After checking for DTCs, the next step is to determine whether any pending or confirmed DTCs other than P050B are indicated. If other DTCs are present, these should be addressed according to their specific troubleshooting processes. Ignoring additional codes could lead to misunderstanding the root cause of the problem with the cold start ignition timing control system. On the other hand, if no additional codes are found, you should proceed to the next step in the troubleshooting guide. This logical approach ensures a systematic diagnosis of the vehicle's issues. The third step in the troubleshooting process involves checking the intake air duct for blockages or incorrect installation. The intake duct is instrumental in directing clean air into the engine, which is vital for the combustion process. A blockage can severely restrict airflow, leading to an incorrect air-fuel mixture. If the inspection shows that the intake duct is clear and correctly installed, the next steps in the diagnostic process can be undertaken. However, if there are issues found, it's essential to address them before continuing. Repairing or reconnecting the intake duct immediately remedies potential airflow problems. Next, you will want to inspect the air cleaner housing for any signs of damage that could affect air intake. The air cleaner housing plays a significant role in maintaining clean air supply to the engine by filtering out contaminants. Any damage could allow debris ingress, which can disturb the performance of the ignition timing control system. If the housing is intact, it indicates that air quality sent to the engine is still optimal. Conversely, replacing a damaged housing can restore the necessary conditions for proper engine function. This step is critical in resetting the parameters for the engine's air intake system. At this stage, inspecting the air cleaner element for dirt or debris is essential. A dirty air cleaner element restricts airflow into the engine, compromising combustion efficiency. The health of the air cleaner element directly affects the engine's performance during cold starts, which is pertinent for the P050B code. Should the element be found soiled, it should be replaced or cleaned thoroughly to restore optimal airflow. Continuing to operate with a dirty air element can lead to further complications, including immediate ignition timing problems and overall engine inefficiency. The next step in the troubleshooting process is to let the engine cool down until the engine coolant temperature, ECT, sensor 1, registers 122 degrees Fahrenheit, 50 degrees Celsius or lower. This specific temperature is critical as it allows for precise evaluation of engine performance and ensures that any timing issues reflect normal operational conditions. Waiting for the engine to cool before proceeding with diagnostics guarantees a fair assessment of the cold start ignition timing control system without overheating factors skewing the results. Maintaining optimal conditions aids in accurate readings and helps in identifying the precise cause of any anomalies present in the system. Following the cooling period, the next action is to clear the DTC using the Honda Diagnostic System, HDS. This reset allows for the system to start afresh, clearing any old fault codes that may no longer be relevant. With the DTC cleared, you can now proceed with new diagnostic tests to observe the system's live performance. It's essential to establish if the DTC P050B returns during subsequent monitoring. By effectively resetting the diagnostic system, any old errors that could produce misleading readings are eliminated, paving the way for accurate troubleshooting. After clearing the fault codes, start the engine and allow it to idle for at least 10 seconds. This period enables the car's systems to recalibrate and allows the onboard diagnostic system to assess real-time data. It is essential to monitor the onboard diagnostics (OBD) status for DTC P050B using the HDS to determine if the issue persists. At this stage, the engine's behavior during idle can yield crucial insights regarding the ignition timing control system's functioning. It is important to record the status indicated by the HDS, as this will inform subsequent troubleshooting steps depending on whether the system passes or fails the diagnostics. During the monitoring of the OBD status, you will check if the HDS indicates failed, passed, or executing for DTC P050B. If it indicates failed, it is a clear sign that further issues exist with the cold start ignition timing control system, thus requiring further investigation. A passed status means the system is functioning correctly at that moment, but could indicate intermittent issues, necessitating a check for poor connections or loose terminals at associated sensors like the CKP and ECT sensors. If the HDS shows executing, it indicates that the system is working on testing, and you should continue to allow idling until a definitive result is presented. If out of condition is shown, return to the cooling step for further diagnostics. The focus of troubleshooting shifts now to inspecting the ignition timing itself. The ignition timing is the precise moment the spark plug fires in relation to the position of the piston within the engine cycle. Ensuring that this timing is correct is vital for efficient engine performance. Any discrepancies could result in poor engine performance, misfires, or increased emissions. If the ignition timing is found to be out of specification, corrective actions will need to be taken to adjust it back to the manufacturer-defined settings, ensuring that the ignition occurs at the optimal moment in the engine cycle. Should the ignition timing inspection reveal issues, attention shifts to the CKP sensor and the CKP pulse plate. The CKP sensor provides the necessary data regarding the position of the crankshaft, which is essential for timing purposes. If either the CKP sensor or the pulse plate is damaged, it can lead to incorrect timing signals, thus causing ignition timing errors. In such cases, replacing the defective components is necessary to restore proper function within the ignition control system. Timely replacement is crucial to prevent further engine performance issues and to ensure overall vehicle reliability. The final troubleshooting step is to conduct the ETCS, Electronic Throttle Control System, test using the HDS. This test evaluates the functionality of the throttle actuator control valve, which plays a crucial role in determining the engine's airflow and overall responsiveness. If the throttle actuator is functioning normally, it indicates that the throttle system is responding as it should, allowing for proper air ingestion to support the control of ignition timing during cold starts. In case the test reveals issues with the throttle actuator, corrective measures will need to be taken to address these issues to ensure that the system is calibrated correctly. After completing all troubleshooting measures and necessary repairs, it is essential to verify that the DTC P050B has been successfully cleared from the system. This can be accomplished using the Honda Diagnostics System, HDS, to check if any fault codes reappear after subsequent engine cycling. A successful verification includes observing that the DTC does not return after a thorough test drive of the vehicle under various operational conditions. Particularly focusing on cold starts. Engaging in this verification process helps ensure that the cold start ignition timing issue has been effectively resolved, thereby restoring the overall performance of the vehicle. Performing preventive maintenance is vital to ensuring the longevity and optimal performance of the Honda Odyssey, particularly regarding the ignition timing control system. This includes routinely checking the air filter and replacing it as needed to prevent clogging and maintain proper airflow to the engine. Additionally, regular inspections of the entire intake system, including ducts and connections, help catch any potential issues before they escalate. Keeping an eye on the CKP and ECT sensors for wear can also contribute significantly to their longevity. By adhering to a strict maintenance schedule, you can mitigate the occurrence of DTC P050B and maintain higher efficiency and fuel economy in your vehicle. In summary, understanding the DTC P050B and its implications on the cold start ignition timing control system is crucial for maintaining vehicle performance. Recognizing the primary components involved and their roles aids in effectively diagnosing issues. Following a structured troubleshooting guide, as outlined, systematically addresses each potential cause, ensuring that nothing is overlooked. It is equally important to emphasize preventive measures to maintain the system's integrity and function effectively over time. The combination of thorough troubleshooting, effective repairs, and preventive maintenance ensures the Honda Odyssey operates at peak efficiency and reliability. Please like and subscribe to the channel. See you next time.